Semiconductor manufacturing testbed flies alongside Starlink satellites on Falcon 9 launch. 2 semiconductor fabrication testbeds hitched a suborbital ride on the first stage of a SpaceX Falcon 9 rocket that launched another batch of Starlink satellites from Cape Canaveral shortly after sunrise Sunday. Liftoff of the Starlink 10 to 50 mission from Space Launch Complex 40 happened on 6:50 a.m. Eastern Daylight Time, 10:50 UTC. Space Force meteorologists predicted an 85% chance of favorable weather for launch. In addition to boosting 29 satellites for SpaceX's internet service, the Falcon 9 first stage booster carried 2 manufacturing pods for Washington, D.C.-based startup Besxar Space Industries on an 8-minute, 19-second ride to space and back. In October 2025, the company revealed it had booked 12 Falcon 9 flights to test the space-based semiconductor substrate manufacturing plants it calls Fabships. In announcing its plans, Besxar said it would use the vacuum of space to produce ultra-pure substrates and precursor materials for the semiconductors essential for electronic devices. We're reaching the limits of what can be built on Earth. AI data centers are straining against power and cooling limits. Silicon is nearing its physical edge, and fabrication plants can't achieve the vacuum or yields that next-generation materials demand. Ashley Pilippisin, founder and CEO of Besxar, said in a statement last year, "The workhorse SpaceX booster flies above the 100-kilometer high Kármán line, considered to be the boundary of space, after it releases the second stage, which carries the rocket's payload into orbit. After stage separation, the first stage booster continues to coast upwards." On a Starlink mission, a first-stage booster typically reaches an altitude of about 115 kilometers before gravity's grip pulls it back to Earth and a landing on a drone ship in the ocean. Besxar says these short-duration, suborbital flights with their rapid turnarounds are ideal for fine-tuning its manufacturing process. The testbed Fabships, called the Clipper class, are about the size of a microwave oven. With a regular cadence of launch and re-entry missions, we can now iterate faster than ever, transforming space into a critical extension of America's semiconductor supply chain, said Pilippisin, who previously worked for OpenAI in its early days. In an interview on the CNBC podcast Manifest Space, Pilippisin said the early Clipper-class Fabships will carry a variety of terrestrial-manufactured semiconductor wafers to see how they hold up against the rigor of a rocket launch and re-entry. "You can think of this similar to the ultimate egg drop challenge," she said. "We want to ensure not only can we get wafers to space, do our manufacturing, but also that we're able to successfully bring back wafers without any type of cracking or damage like that." Besxar has received support from graphics and AI chip maker NVIDIA's Inception program for startups, and SpaceX is listed as one of its investors. The company originally planned to start Fabship testing aboard the Falcon 9 before the end of 2025. Sunday's Falcon 9 launch will be SpaceX's 60-second Starlink delivery mission of the year as it continues the expansion of its Internet from Space service. Deployment of the stack of 29 V2 mini Starlink satellites from the rocket's second stage is slated to occur 1 hour, 3 minutes, and 31 seconds after launch.